just reading directly from the problem set here, it says how many joules of heat are required to raise 25 grams of ethyl alcohol from the prevailing room temperature of 22.5 degrees centigrade to its boiling point of 78.5. So look at how I've distilled down this problem here. Okay, the problem says how much energy? Question marks. That's what I'm looking for. Okay, the mass of your ethyl alcohol is 25 grams. And we are going to take that temperature from 22.5 to 78.5 degrees centigrade. Again, just like the problem that I worked for you before, you're putting it onto the stove, heating it up. Okay? Now, let's go ahead and write down our equation. Q equals MC, final temperature minus the initial temperature. Now, we are looking for Q. So no big deal. Let's just write down Q. What's the mass? 25 grams. Okay. Now we're looking for specific heat. But remember, this is ethyl alcohol, not water. So we have to get our nose into a table, right? Nobody has these things memorized. And we are going to find out what the specific heat of ethyl alcohol is. I've got it right here at 2.138 joules per gram degrees centigrade. Okay. So on your test, you just flip somewhere in the back, that'd be given. Alrighty. Now what's the final temperature here? 78.5, right? And that is about where alcohol will start boiling. Alright, minus 22.5. Okay, so pulling out our nifty calculator here. 25 times 2.138 times 78.5 minus the 22.5, enter. What are you guys getting? Joules? That guy there? Did anybody not get that? Wonderful, right? You guys are doing good so far. Okay, so I told you that these specific heats are given in tables. All right. Well, what would you do if you didn't have a table? Well, you would have to be given what? Energy, mass, and the temperatures. And then could you solve for C? Sure you could. And that's what's going on in this next little problem here. Now, as a matter of fact, in the lab today, or the demo that I'm going to do for you in a few minutes, that's exactly what we're going to do. We're going to have an unknown metal. And we're going to see if we can find the specific heat of it using a thermometer. Okay, so let's get started. We're going to have the heat equals mass times specific heat times the final temperature minus the initial temperature. Well, let's take a look, see at what we've got here. Okay, do we have the heat? Yes. Do we have the mass? Yes. Do we have the final temperature? Yeah, and how about the initial temperature? Yeah. The only thing we don't have is that C. So who's got a bright idea about how to isolate that? What could you do algebraically? All right, there we go, hitting the divide by, right? First, let's divide by M. So if we did that, do you see how that cancels? And of course, by algebra, if you divide on the right, what you got to do on the left? Divide. Now, can we divide by T sub F minus T sub I, the whole quantity? Will that cancel out for us? Sure it will. And, of course, we got to do that over here, though. Do the whole quantity. All right. Cleaning this up a little bit, here's what we've got. We've got the specific heat of our metal equals what? The energy divided by the mass times the final temperature minus the initial temperature. All right. Now, what is the heat? Well, that's cute. All right. Do you want to use kilojoules or do you want to use joules? Joules. Now, why do you want to use joules? Well, it turns out that all the values in the table are in joules. That is a standard way to report that. it would not necessarily be wrong if you did not use joules. Okay? So you're the scientist, you can use any unit you want, but it's always good to have it standardized. Okay? That way everybody's kind of reading and thinking the same way. So how are we going to do this here? 5.866 kilojoules. Well, here's what I know. I know that in 1 kilojoule there is 1,000 joules. Do I know that? Okay, so what does that mean? That means my Q here is 5.866 joules. Is everybody happy with that? Okay, what is my mass? 250 grams. All right, my final temperature is 100 minus 22 degrees centigrade. So what unit am I in now? I'm in a joules per gram degree centigrade. Now what unit is this thing in? Joules per gram degree centigrade. So do you think we did the algebra right? Yeah, okay. This dimension analysis thing, in other words, checking your units is always good. I mean, I do understand that the algebraic manipulation here is not extremely rigorous, but later on it will be. And you always want to be sure, hey, have I got the right unit figured out here? Okay, if not, then go back and you did something wrong. Calculator, that's what we're going to do, right? 58.66 divided by 25.0 divided by 100 minus 22. What do you guys get? 0.301 joules per gram degree centigrade. Yes? Now what did you get? You got a different answer, but she also had a different unit. Who kept theirs in kilograms? One person. Okay. Now if you did such a thing, that would be okay. Actually be a smaller number. 3.01 times 10 to the minus 4 kilojoules per gram degree centigrade. Are these two answers the same thing? Sure they are. All right. The only thing that's different is units. I mean, it's the same way if you weigh yourself, right? If I ask you how much you weigh, which I would never do that to a lady, right? But you would probably give me the answer in pounds. But would it be wrong if she gave me her answer in kilograms? No, just a different unit. Same way with specific heat. You know, a normal human would give me this answer in joules per gram degree centigrade, but it is not wrong if she gives me her answer in kilojoules. Does that make sense to you? Okay, so how are we doing? Are we doing really good? Okay, then let's see what's happening here.
Divided by, and you got a parentheses, right? 78.
78.5. Well, which one you doing? Yeah, you doing 100 minus
22.
Yeah, there we go. 100 minus 22.
And just, okay, I see what I'm messing up.
Now, that's still going to be messed up. You need another divide sign right there.
Yes, I do.
All right.
Let's see.
You can navigate using these things here. Go up there. You go. Now you have to hit second insert. There you go. Then hit the divide. Yeah, just hit. There you go. Now hit the enter button. That'll do it.
That works.
Okay, that's got it. Okay. Are we doing good? We ready to move along? Okay, well let's crank it up a little bit then. And I'm going to crank it up with problem number 21. All right, so you guys go ahead and be perusing over that while I get me some board space here.